Welcome, everybody. We're going to be working on our Chapter 7 programming exercises tonight. Our grand topic for this chapter is working with external files and working with exception handling or errors in our program. You will notice here, and I do have like the e-book open, that there's other categories in this chapter that we don't really dig into super heavy. But I would encourage you, if you have the time, to read through those and you can ramp up your skills a little bit more. I'm hitting on what I think are the highlights of the chapter and the pertinent information we need. All right, let's look at this first exercise here. So the first one says, write a program that carries out the following tasks, right? And this is kind of like in pseudocode declaration. Open a file with the name hello text. Store the message hello world in the file, close the file, open the same file again, read the message into a string variable and print it, right? So open, write, close, open, and print, right? And why? To prove that it works, right? So we are going to be dealing with files. So one thing that I'm going to do here is I'm going to open up a brand new File Explorer tab, and I'm going to dig into my file system. Now, you see, I'm not like being hasty and jumping into my IDE right away, right? And my web students know this because in web, I hammer this all the time because it's super critical. File management first, folks. You know, it's like one of the most basic skills that we have. And it becomes really, really important when we're doing stuff like this for a number of different reasons. And I'm about to show you a couple of them. So I'm going to locate the folder where I am putting my work, right? And this has been my normal pattern. So I have a Python folder. I teach multiple semesters, so I have every semester is in a separate folder. And then I'm going to go ahead and create a new folder for Unit 7, which is the unit that we're working on tonight. All right. So because each of the exercises that we're working on, and I just went into the folder if you're wondering, is going to be working with files instead of our previous pattern where all the programs just go in the same folder. I'm going to create subfolders for each exercise on purpose, right? And this is kind of the pattern. You don't really have to do this. You can kind of work around it with clever naming of files, but I'm just going to say exercise 7.1, and I made a folder for it. Now I'm going back into that folder, and the first thing I'm going to mention is I am working on Windows 11, right? So the way that my file management tool looks might look different from yours if you're working in Windows 10, right? With Windows 10, there's the ribbon bar, which for whatever reason, they removed it from the File Explorer in Windows 11, and I had finally gotten used to it after Windows 8, you know, and I'm like, all right, that's all right, I can work with this. And then they got rid of it again. I'm like, what did you guys do, right? And I know there's hacks, you can bring it back, but so I'm working on Windows 11 is long story short, which means that my menus may look different than yours. Now, one thing I want you guys to do is, as you're working with your file system, is I need to make sure that all of you are in a mode where you can see your file extensions in your folders. And I will argue that I think all the IT people should always work in this mode, right? Normal people can work without seeing their file extensions because they don't know how to manage their files anyhow. IT professionals, in my opinion, must know where their files are located and what their file extensions are, right? So web people, you've heard this speech before. AI data people, you're hearing it now for the first time, but it is really, really critically important. All right, so how do I know if I'm seeing my file extensions? Well, let's just do an experiment. I'm going to right click in the empty part of the folder here, and I'm going to say new text document, right? And I'm going to call it, whatever, like I normally do. All right, but notice after I've created it and saved it, I can see my file extension. The file extension is the .txt at the end of the file. Now, for many people, by the way, they're not seeing it. So in Windows 11, I'm going to go to this triple dot menu, go to the options menu, And I'm going to pull this to the side here. I'm going to go to the second tab, the view tab. And then normally this checkbox right here that I'm kind of jumping over that says hide extensions for known file types. By default in Windows, this is checked. So I'm gonna turn it on just to show you the difference. Now I want you to notice I'm in the detail view of the file, right? So I'm in this. I'm not in like icon mode or small icons or even list mode, right? I'm in detail mode, and this is for me my preference, right? Is to be in detail mode because I can see the date, the size, the kind of document. But there's no indicator here that this is a text file by looking at the file name. The indicator really is the text document, and then if I double click, what program opens it? Well, in Windows, it's Notepad is the default. If you happen to be on the Mac OS, right? And I know I have a few Mac people here. The Mac's got the same issue. You can go into the Finder, find the preferences, and there is a spot where you can reveal or show the file extensions. The Mac people don't generally like that. That's not the norm for them. But I argue, even on a Mac, you should see your file extensions. And so if you're coming up in this view, I want you to be really careful. So let me show you what happens when you're in this view. You'll click on new, you'll say text document, and then you'll say whatever .txt. Well, I just created that file, and normally if the file already exists, it wouldn't let me do it. Notice it's still a text document. So it looks perfectly legit. Now, if I go to the options menu here, right, once again, back to the view tab and uncheck that box, hide extensions for known file types, hit apply and okay. Look at what actually the second file I created, look at what happened to it. It's whatever .text. See the difference? As an IT professional, you owe it to yourself to go to options, go to the view tab, and uncheck that box. Hit apply, then hit OK. And your whole file system will alter. And that's the mode you should always stay in my humble opinion. Right? I can't coerce you to do that, but I've seen so many problems where I really see even more significant problems. And my web students in the class will know exactly what I'm talking about. When we do like index.html, right? And you're in the other mode, and then it really ends up being .txt. And then it doesn't work as a web page. Right, web students? Right. You probably found that one out the hard way. And so it makes a whole lot of sense to always show your file extensions in your operating system. Same is true on Mac. Same is true on Linux even, but Linux usually shows them by default. Windows does not show them by default, but IT professionals should show them by default. All right. All right. So I'm going to go ahead and delete all those files because I don't need them. But I want you to understand that it's best to be in that mode, because as we're creating and working with files, there's reasons why you want to be able to see them and to access the full correct file name. You don't want to be jumbling about with basically nonsense, All right, let's take the pseudocode instructions, the ones that look like they're kind of handwritten here, and let's drop them into Spider. And I have already opened up Spider, ready to work. I'm going to do a save as, and I'm going to put it in that new folder. So let's go to my Python class, correct semester, correct unit, correct exercise. And then I'm going to name this exercise 7_1. Ready to code. Now I'm going to take the instructions that we copied from the book, And I'm just going to put them here for easy reference. Okay. All right. So we have to open a file open a file with the name hello text. Okay. What is this telling me right off the bat? Didn't tell me to create the file. It said that to open it, which means it's got to come from somewhere, which means, yes, I have to create it. So I do have to create it. So let's go back to our file system then. And notice I'm in that folder and I'm going to say new text document and I'm going to call it hello. Okay, so there it is. If I double click and open it, it is indeed empty. There's nothing in it, right? Why? Because I didn't put anything in it. Correct? Correct. Okay. So there it is. So now we have a file to work with. All right. So I'm going to do a couple like really kind of goofy little examples here, but I'm going to kind of build this up as we go. So keep that in mind. But basically, I want to take the file, I want to store a message, and then I want to write it to the file, close the file, and then hopefully have it work. All right, so let's do a couple of things first preliminarily. We're told what the message should be. So I'm just going to create a variable called message, and then it says, it should say hello world, but you can say whatever you want. And I'm just going to say hello, Milwaukee, and let's do an exclamation. There you go. The other thing is we're dealing with an external file, right? So I could always hard code the name of the file into my code, or if I'm using the file multiple times, I can store the file name in a variable. And then if I change that, I can have it update globally in the program. So I'm just going to create another variable called file name. And what file name am I using? I'm using hello txt. I want you to be ultra mindful about this. Python is hyper case sensitive. So back over here, if I name this with a capital H, this code is not going to work. It would throw an exception, right? So this is one of the things, input output error because it's not finding it. All right. Oops, didn't mean to take that double quote with me. All right, let's move down a couple of lines. And now we're going to like do the couple of basic statements here. And then I'm going to then put it into a try block to show you how that works as well. But I'm going to do basics first. So we have a couple little weird conventions that we do when we're doing this. But often when we're dealing with a file that we're reading, right? So if I was just reading in a file, I would probably name it in file, or what a lot of us do is we abbreviate and just say INF, right? If I'm pulling in a file where I know I'm going to write to it, I call that an out file. And a lot of us will abbreviate that as outf, right? These are just weird little programming conventions. Ultimately, you can use whatever variable name you want, but it is a variable name, and I'm going to use outf. That's going to be my thing, right? What am I going to do in the program? I'm going to open the file, and then inside those parentheses, well, what am I opening? There's two parameters we use. The first one is the file name. That's stored in a variable, so I just have to type the variable name. And then I have to indicate, am I reading or writing? Remember that Kahoot slide, right? So W indicates we're writing. So I'm opening the file hello text for writing. Right. Then I'm going to issue this weird command. So I'm going to take that out file. So like that file now resides in that variable called outf, the whole file. All the contents are in that variable. Remember, each line is in one list position, whatever. All right, so that's maybe not quite so important right now. All right, so then I want to take that file and write something to it. What am I writing to it? The message I have above. So this command takes a string basically and injects it into the file. All right. Then, you know what? I'm done with the file. Then we issue the close command. That's how you close your file. So I opened it for writing. I wrote a message to it, and then I closed it. Okay. All right. Then the next part of this is now I want to open it again. I want you to think about all the processes here. Now we're going to open it again. We're going to read it in, store it in a variable, and put it on the screen. All right, so I'm going to do those steps. So here's that part. So I'm going to do, this is going to be an in file. I don't need to change the file, so it's just inbound information. So I'm calling it INF, right, for in file. I'm going to open that file. We still use the same open command. I'm still opening the same file name, but this time I'm using the R switch for read only. We're just reading it, not changing it, right? Then we're going to take that file, right? We're going to set up a variable called words, and that's going to hold the in file after a read line. So remember what this does. We learned about this. The read line command reads through the file one line at a time. Each line goes into a list position inside the variable called words. We only have one line of text. We're using one list position, right? So we read it into that variable, and now we're closing the file. So in file close. All right, so we did the maneuvers. We opened it, wrote to it, closed it, opened it, read it in, and closed it. But now we have to put it on screen. So now I just need a print statement. So I'm going to say print. And you know what? I'm going to use string interpolation here. So I'm going to use the letter F. Excuse me. And I'll say the file name contains I'm doing a carriage return here. Oops. And then I'm simply going to output the whole file. And we know what's in it. It's one line of text. And so this will do the output. We need to test this. Does this work? All right, so let's do this and see. So saving, here comes the run. And that is really, really small, but I'm going to click over there and enlarge the console a little bit. And notice the file hello text contains hello Milwaukee. So it worked. So I was able to do all of what it said here and do it correctly. All right. Not satisfied with that. And let me show you why, because I'm going to build in the exception handling part here and shows you what happens if, okay, let's just say that you are a maverick or whatever your situation is, and you didn't listen to me. You didn't name it all lowercase, and you decided to put in a capital H. And I'm going to go back to the program and run it. Oh, darn, Windows doesn't care. All right, so this is kind of a teaching point too. This is one of these goofy little things, because we have Windows running our operating system, and Mac users, don't laugh, you have the same issue. The Windows and the Mac OS don't care about the capitalization of file names. It works around it. However, if I do this on a Linux system or a Unix system, it will break horribly because those operating systems don't do this automatically. So what this is telling you is the Windows OS and the Mac OS are dumbed down so that the users can do stuff. Hey, it worked. That's what it's telling you. All right. Well, what if I wasn't really good about naming this, right? And I did the hello text.txt thing. And that's certainly different, right? Let's see what happens in that scenario. Here comes the run. All right. Yeah, it's still working. Why is it working? Well, here's the why. I have a separate file here called hello text. I'm going to delete it. All right. You know what? I don't believe it. The naming isn't catching on. So let's just, can we call it something else? And I get really goofy with this stuff. Okay, whatever. I'm going to call it something completely different. So now it's going to fail for sure. Right. All right. Watch what happens. What? Yeah, you guys are laughing at me, but this is an intentional demo, right? This is completely intentional because what's happening is it's not finding it. So it just, I mean, we're opening it in write mode. So what's it doing? It's creating it. So here's the teaching point here. If the file doesn't exist, the write switch creates the file. How do you like that? Pretty nifty, actually. Right? Yeah, totally. All right. So still, this, you know, we're not making it fail, right? However, if we did something, and maybe this is a better way to do it, instead of hard coding a name in there, if I did whatever dot text, now I can break it, right? You guys hedging bets on this? Now it still works. So the right switch, that's really kind of the grand theme of all of that is the right switch. And if you want to put in your comment here, so I think it's fascinating. Okay, so let's just do a couple of things though, right? Because we're doing the right switch, it's always going to create. But let's just say that it had the potential of failing. What we might do is we might do a try block. So I'm adding the keyword try. I'm highlighting the lines that follow, and I'm pressing my tab key to indent everything equally. Do you guys see how we did that? That's a pretty slick trick, right? And we're going to put in an exception handler. And the way that you do, as you say, except IO error. So in other words, if it happens to fail, I am going to print a message on the screen and I'm going to say, and some people will print the error codes. I'm not really into that. So I'll just say something goofy like file not found. Right. Now we know from like doing this though, this isn't going to fail no matter what, is it? Yeah, it isn't going to fail unless in between when we ran this command and closed it, it somehow got deleted. Yeah, it's not going to happen. But this is the general procedure. And the other thing I usually like to do, right, and this is just me being kind of like a maybe slightly anal retentive or something, is whenever I'm making a maneuver with files, I often like to put in messages so I know that it worked. You know, something like this. So the user knows that it worked, right? And if it fails for some reason, this message would come up on screen. Now we know in this scenario, because we've tested it, right? This exception would never happen. But I would still, as a programmer, prefer to do this just in case. Maybe there's some technological reason I'm not anticipating that would break it. Okay, another thing that I could do, right, is all right. You want to see the try catch actually work? Is I could not write the file, I could read the file, right? Now you feel how I'm going to make it break. So now I'm going to delete it. I don't have that file in there. And now when I run it, it is throwing an exception, right? And actually, you know, now that I think about it, it might be this that's throwing that. Right, let's run it one more time, right? Yeah. And actually, okay, let me control Z that. All of this needs to go. All right. Now let's try it. There we go. So there's just the exception handler, because now it's not creating it with the right switch, and it's truly not finding it. So there's your exception handler kicking in. Right. So that you guys don't need to make those maneuvers, by the way. I'm just doing it for the sake of example. All right. So if dealing with an incoming file can cause that error, then dealing with just reading a file in can potentially cause an error too. So all of this should really be in a try block also. So I'm indenting all of that once again. And once again, I would have an input output exception, and we would call it IO error. And then we need, your error message. I suppose you can use the same one, right? So this is if it's trying to read the file and then for some reason it's not there. Is this excessive for a little program like this? Yeah, totally. Right. But I'm trying to show you how it works. Right. But generally speaking, when I'm writing a piece of software and I'm interacting with input and output files, you need to do try catch blocks. And I want you guys to know something saying that, because in Python, we call it try except, but in every other language, we call it try catch, by the way. So that is the first exercise. Oh, wow, it did it. And did it write the message to it? Doesn't seem like it wrote the message. Let's see if it.
You have it commented out.
Oh, yeah. Thank you, Alex. All right, let's run that again. You're right. The right message part was commented out. Thank you, sir. All right, there we go. It works. And
How would you make it? How would you make it actually display the proper error code?
You have to basically allow it to read in the error code, and then you could append it to the message as a little object. That's, for example, like when we do Java and C#, that's a lot more common. I do find it, at least from the user standpoint, pretty irrelevant. Like, what do they care what the error code is? That's kind of my take on it. All right. It is 8:58. Let's take a little bit of a break here. Let's do a 5-minute break, and then we'll come back and code through the rest. All right, we're back from our break. And before I get to the next exercise, I'm going to do kind of basically the same thing I just did here, which is I'm making a new folder for the next exercise just to keep all the text files, separate, and we don't like confuse them. And let's read the instructions. I suppose that would be helpful. Our next exercise is 7.2. All right, and this one, all right, this is an interesting one. It says, write a program that reads a file containing text, read each line, and send it to the output file, preceded by line numbers. If the input file is, Mary had a little lamb, basically what we're going to do is we're going to append to each one of the, strings of text this information and basically give it line numbers. Now, you could do it with this simple little block of text. So if you have an electronic copy of the book, you can literally just grab, Mary had a little lamb. I don't know if that lets me copy here. And just for, if you guys don't want to type, there you go. Lazy people, I've typed for you. How about that? And, hey, we have the internet at our fingertips, so we can just go, and if you don't want to do Mary Had a Little Lamb, what I usually do is I just pick songs that I like or whatever and just use those words. So that's what I'm going to do. All right. So let's kind of think about this here. First thing we're going to do is we're going to read a file containing text. So we already need to have the file created. Get the difference here, right? So we're not like pre-creating it. We want a file that's already basically there. So, and I'm trying to get all my windows arranged here, so I apologize. I'm just trying to find my other file folder with all my files already open. And of course, I'm epically failing. right. Did have it open, then I moved it, moved it all in. All right. So let's start by creating some of the basic code here, but we are going to need a file that's going to contain some uh, some information, right? So the other thing that I want to point out here, and whenever I see that reads a file containing text, so what they're telling me here is that I'm going to prompt the user for the file name this time. I'm not going to hard code it, right? So talk about the possibility of having a crash. Right? There's a really good one for having it for having a crash. So I'm going to show you all my little goofy techniques for doing this here. But it seems to me that I need to start with a file. All right. And I'm, from the old version of doing this, and I'm not really a big fan of like recreating stuff, but I created a file called input-bb, and I'm going to show you what's in it. Right. And so I took like the first few lines of the Beatles song, Blackbird Singing in the Dead of Night, if you guys know that one. Right. So if you don't want to use Mary Had a Little Lamb, by the way, you can use my file, which I just put in the chat. So you can just grab the whole file if you wish, right? It's only 4 lines of text, whatever, but that's the file. I do want you guys to notice the file name, input-bb.txt, and it's got to be exactly that as we're manipulating it. All right. So I also need to make a copy of this because this is actually in a different folder. So I'm going to put it in the folder that we're working on tonight. So you see, I'm trying to be careful about where I'm going and where I'm putting it. So I'm just going to place it in there like that. Okay. So now let's go to Spider and start creating the program. So new file, save as. Make sure you put it in the other folder though. So go up a folder level into your new folder. And then I'm going to call this exercise 7_2. So a couple layers of different things that are happening here. We are going to be interacting with the user. All right. So that in and of itself can cause exceptions. So I'm going to start with a try block right off the bat. Right. And if I have a try block, well, you know what? Let's go down a few lines, come back to the margin. We probably have to have an except. And I will tell you right off the bat that this is going to be an IO error if they don't enter the information incorrectly. So in other words, we're going to let the user type in the file name. Guess what? That's the highest risk situation for them not doing it correctly. And so I'm thinking of like, okay, I'm going to have to come up with an error message right off the bat, right? So I'm going to, all right, so here's how I'm going to proceed here. So maybe this is a little backwards for you, but I'm going to create a variable and I'm going to call it input name. That's where I'm going to put the file that I'm bringing in, and I'm prompting the user and I'm saying, enter the input file name. Okay, so I'm going to prompt them. They're going to type in the string of text, and then provided they do this correctly, right? So this is why it's in the try block, because it might not be there, right? That's the one reason why we're doing this. Then I'm going to store it in the in file if it is there, and I'm just going to use my open command. So I'm going to put whatever name they typed, hoping they typed it correct, right? That's the file we're opening. And I'm not going to write it. I don't want to change the original file. That's not what it told me to do. I'm reading it. So I'm doing an R. Okay. So just this could generate an error. So here's my error message. Okay. And I'm just saying error, input file, I'll list whatever they typed, not found. Okay. I think we need to test this already, right? Can we do that? And you know what? Let's just put in a little print message here. And this is a temporary message, by the way. So if it works, we'll say success. If it fails, we'll say error. All right. So I know that I called it input-bb.txt, all lowercase. Running it, and I'm gonna, of course, make it fail. Right, that's what I do. Sometimes it's better to make it fail. It says error input file whatever.txt not found. Okay, correct. It's not there. It's not in the folder. Now let's try it and try to make it correct. Right. So now I'm going to say input-bb.txt. Success. Okay, so that so far is working. That's kind of like, I'm going to call this the outer shell of what I'm building. Because let's face it, if they type something in wrong, I mean, none of this is going to work, right? So we got to handle that piece first. All right. So instead of having maybe a simple message that says success, I might I think, well, you know what? Let's worry about that success message later. Okay. So we did this step. Okay, so we prompted them for the input file name, and we were able to open it and accommodate for if it's bad. Right, now we have a separate procedure. Right, now we have to tell it what the output file name is. So I'm going to put a try block inside of my other try block. How about that for a mind bender, huh? All right, and then I'm also going to put in an accept. And I do need to qualify it and say, well, you know what? I don't think I need to qualify this one. Right? And I'll explain why as we kind of move forward. Let's think of the mechanics here first. So now that they opened up a file, read it in, now we have to figure out the output name. So that's what I'm going to name my variable, output name. And then once again, we're doing an input. We're prompting the user. And we are going to say, what did I say last time? I said, enter the output file name, right? Well, the converse of the first message. Okay. We're going to store that. Now, I'm anticipating this to be a output file. So I'm going to call it outf. And then I'm going to open this with the output name that they gave me. And that's going to be in write mode. So I'm putting in the W switch, basically. All right. Another thing we have to think about, right, as we're doing this is now that I've read the file in, I'm getting ready to write the file. So the W, what I just did in line 13, I've already created the output file, right? So now I have to think about the stuff that's going into that file if I want to write to it. And I'm going to be numbering the lines of the song or the poem or whatever I dropped in there. What number am I going to start at? Well, 1 sounds pretty good. First line, that kind of thing. So I'm going to set up a variable called number and set it at 1. Right. When I output each line, I will then increment it. Right. All right. Writing each line, adding something to the front of it sounds like a repetitive process, doesn't it? So we're going to do a for loop. So I'm going to say for each line in the in file, the incoming file, I'm going to do the following, right? I'm going to, what did I do here? Oh yeah, I'm going to write. So I'm going to take my out file and I'm going to write. Well, what am I going to write? Well, look at the instructions. /* space, the number, space, / space. That's what I'm typing in there. You got all that? Right, exactly. I'm sure you have it emblazoned in your memory. Right. So here's my /* space. Then I want the number, right? So I'm going to concatenate the number, but I need to convert the number to a string first. So I'm going to do str number. Then I'm going to concatenate the last part of it, which is space * space. And then concatenate the line that was just read out of the file. So what the for loop does is it will read each line in the file separately. And now I want to include that line here. It's just going to have the numbers and the stars and the slashes in front of it. And so that's written to the file now. Then I want to take that number variable I created and plus equals 1 to it. So I'm incrementing it by 1. And the writing process is done. So remember, don't forget to close your file. So I'm closing the in file and I'm on a separate line. Right, I didn't want to do it on Alt F dot close also. So I'm closing both files. And I often do this. Don't if I can type it, don't forget to close your files. Don't forget to close your files. Right. All right. So at this point, it didn't ask us to put the file back on the screen. We're going to have to actually go look at the file. Right. But how do I know it succeeded? Well, I'm going to do a little error or not a success message, right? So usually we do error messages. Now we're doing a success message, right? And so I'm going to say file processing complete. Your files have been changed. And we'll go back to the file system to look and make sure that really happened. Right. If this process for some reason fails, I want an error message to indicate that. And the only thing that would trigger it to fail is if the input file isn't there. Okay. So I'm trying to think, is there anything else I need to do here? I'm looking at my solution code and the answer is no. That's all the code. Right. So let's check this out and see if it works. All right. So I'm going to prompt. Is there, I'm trying to think, is there any spot in here where that, I don't think there's any spot in here where it's going to fail. All right. So here's the run. We already tested if I put in the wrong input name, right? But let's do it again. Right. There you go. That still works. Thank you. All right. Now let's try to actually put in a for real one that we know is there, input-bb.txt. Okay. Enter. Now we have to put in the output file name. So I'm going to say, how about something clever like output-bb.txt. Makes sense, right? Pressing enter. It says file processing complete. Your files have been changed. How do we know? Got to go look. All right. So I'm going to bring up the file. All right. Looking at the dates. You guys noticing this, right? So this one's from a few years back because that's when it was first created. But this one is from tonight at 9:20 p.m. Sounds correct. Let's open it. And there we go. Notice the additional characters at the beginning of each line. If you want to use something bigger or more verbose, you're welcome to. And as I go through the night, I'll use bigger files. But let's just make a simple file work first. Alex, I see that you've got your hand up, sir.
Yeah, it's
all right. Now we're going to move on to exercise 7.4, and it says write a program that reads a file containing 2 columns of floating point numbers, prompt the user for the file name, and print the average of each column. Okay. Whoa. Step back a second, right? This is what your brain should say. It's like, wait, now all of a sudden I'm like processing numbers and columns? Yep. Right. This is actually like, all right, data analytics students, right? This is like your first lightweight introduction to some of the heavier lifting you'll be doing later on when you're in the data analytics program. Is a lot of stuff like this, real frankly, right? All right, so the first things first, you guys are going to need, and I'm being really careful about which folders I'm in here. All right, so this is the previous semester. Let's move the previous semester over. I think this is kind of neat about Windows 11. They now have tabs in their file explorer. I don't know if you guys knew that or not. But for this exercise, I think we'll use this file. So here's a file, and I actually have, okay, I have two input files. We're going to use both of them, but I'm going to show you how to like have your code adjust to one column or two columns. So the first file is coming in the chat. So you guys can use that one. I'm going to borrow those two. And I'm going to create a new folder for exercise 7.4. And then I'm putting those files here. And I think I did copy and not cut, hopefully. Yeah, copy. Okay. Okay, so the one that's entitled input one, it's got two columns. The one that's entitled just input's got three columns. And I want to look at the information in here first, and I want to like basically show you guys a couple things about text files, right? So this is a very, very primitive text file, and this is kind of one of the necessary steps of doing data analysis, by the way, is to look at the data that you're dealing with and the format in which it's stored, so you understand what you're processing when you write code, right? So for example, I have the number one here, and you watch what I'm doing with my cursor. I'm using my arrow keys to arrow through the columns. And as I press the arrow key once and again, and again, and again, and again, and again, you'll notice that, okay, well, the cursor seems to move around just fine, but I'm noticing this is really kind of weird right here in between the columns. You guys seeing how the cursor jumps? And that's because this isn't, for example, a space in here, because that's what a space would look like. It's a tab stop. So there's a tab stop in here. And so two really common formats for data to be extracted from a database or a complex collection and then put into a text file. One is where you take the values from like a spreadsheet, and each column is separated with a tab in between the information. We call that tab delimited, right? A tab delimited file. Or the other common format that we see is what we call comma separated values, where the values are separated by commas. So like, in other words, this would be one spot in a spreadsheet. This would be a separate spot in a spreadsheet. And when it transmits to a file, the commas go in between instead of having columns. All right, so two different ways to do it.
I think you shared the text. I just downloaded and it was from the last exercise.
Oh, you know what? Alex is the only one that got it, because Alex texted me directly and he said the same thing. So I responded directly. Okay, so all right, so here's the first one. Here's the, oh, I lost the second one. Let me try that again. There's the second one. Thank you for saying that one. I would have just kept rolling for hours. All right. But the point is, however this is put together, either with tabs or with commas or with spaces, any of those things, we can code around that and have Python read in here, recognize the fact that I've got two columns of numbers, and then, take this number and put it in one data set, take this number and put it in a different data set, and then process each data set separately. That's what we're going to do. But before you do that, and so once again, this is why I keep emphasizing this, whenever you're processing data from an external source, you need to know the format of your data and how it sits in the file. Is it tab separated, comma separated, space separated, not separated, whatever, but you need to know the lay of the land, basically. All right, so I'm going to close that. So that's the one column version and the two column version, and we'll play with both. Okay, so to the code. All right, so here we are creating another new program. Do a save as. Remember, it's going into its own unique folder, so you got to come up a folder level. You're going into 4, This is going to be entitled exercise 7_4. All right. We're going to keep using try except statements as we're doing this, right? Just to kind of enforce that as a good habit. All right. So I'm going to start with, and yeah, I'm switching over to copy paste here because I see us running out of time pretty quick. So first I'm going to try, I'm going to prompt for the file name and enter the file name, right? So the first one we're going to try is input1.txt, right? And let's have an exception if it doesn't work. Now I want you to notice, I'm not worried about the type of exception here. I'm just worried whether it worked or not. So that's why I omitted it the last time. I forgot to mention that. So you can do that. That's a very simple way. You don't even have to worry about what type of error it is or what the error code is. It either works or it doesn't. All right. So I'm accommodating for that. So that's reading in the file. Going back to the margin. All right. Now we got to process the data. And you know what? This may or may not work because we don't know, like, first of all, okay, we know we got the right file if we get past this point, but we don't know what is in the file if we don't look. And so we also are in a situation where we want to try block again. The other thing is whatever the errors that it might generate are, I do want to have some sort of an except statement, right? And okay, so I'm just laughing at my previous failure message, right? Here's my previous failure message. Epic fail, your program stinks. All right, that's in poor taste. But when I wrote it, I thought it was humorous. So you can put in whatever error message you wish. All right. We have a bunch of different tasks to do here, though, right? So if we're going to take columns of information, total them, and average them, right? That's what we're supposed to do. The first thing that I'm going to do is I'm going to set up some variables to do the calculation. So I'm going to keep totals apparently. So let's get a total one column for total, for the first column total and a total for the second column total. And then because we're doing an average, we also want to keep count of things. So I'm going to have a counter and set it to 0. Now we're going to want to read in the lines from the file one at a time. So I have to read in the whole line with both columns, right? And then we have to find a way to split that apart. Reading in information from a complicated file or data object, right? A loop is what we use, right? So for here, I'm going to say for each line in the in file, right? For each line in the in file, we're going to do the following tasks. All right. Remember that one goofy thing that we saw in the Kahoot? I'm going to take the line as it comes in and split it into parts, right? And so the line dot split, and what does that do? It looks for separations in the content, whether it's a tab or a comma or a space, whatever, and it'll split it into what it thinks are logical words. And that's actually how they're coming in. So this is kind of another thing. When we're reading stuff in from that text file, it's coming in as a string. It's not coming in as a number. Here's another conundrum. So all of that has to be converted. This took the columns and put them into parts. Parts is a Python list with multiple storage positions. Each column will go into its own storage position with the split command. All right. So now we need to convert those. So for total 1, I'm going to plus equals to it whatever is in parts position 0, converted to a floating point number. And I'm going to do the same with the second position, which is parts 1. So both of those are totaled. And every time I go through the loop, I'm going to increment my counter by 1. And that's all the processing, folks. That's it in the loop. All right. So we're done doing that. So in file, close. Files closed. Close your files. Don't remember? Close your files. There. Now you will remember. All right. Next step is to calculate the average of each column, because now we have the total and we have a count. That's all we need to do the averaging, right? And that's done like this. So creating new variables, average 1, which is the total divided by the count. And you can extrapolate the next one, I'm sure. Average 2, which is the second column, divided by the count. Then we just need to display the results. So we are taking the first total, first column total, and I'm going to display it. See my strategy here, right? Because this helps show me that it's all correct. I'm going to print out my count. And then I'm going to display it on the screen. And I'm doing this incrementally here. And I'll show you why afterwards. Right. So I'm going to show the averages of each column. And I'm doing that technique where you drop it in and I'm rounding to 4 decimal places. Right, and that's all the code, folks. You see it all on the screen right now. So there it is, the whole program. All right, so I'm going to go ahead here, hit the play button. Enter the input file name. I don't know, I forgot. Let's see what happens. Okay. It caught it, right? Gave me an error message. All right. But this time we'll be serious. We are going to use input 1 first. So input 1.txt. Says the total is 21 for the first column, 15.7 for the second column. The count is 6. The average is 3.5 and 2.6167. All right. Do I trust that? Well, you know what? Not necessarily, right? So what I would recommend in that situation is that you do, okay, so 6 plus 5 is 11, 15, 18, 20, 21. Total 21. Okay, count to 6. 6 divided into 21, 3.5 sounds right. Okay, so it seems to be working. But really, you should have test values, know what the answers are, and check your scores. So that's with 2 values. All right. Now, if I look at that second file in that folder, the one that's got 3 columns, and notice how these are slightly more complex numbers, right? How would I accommodate this? Well, very, very simply, and I want to show you how quickly we can adapt Python to deal with another column. I would add another total column. And of course, that's going to be total 3. I would repeat this process here for a third column, except we'll call that total 3 and parts 2, the third position. And we would add another average. And notice I'm updating all the numbers here to make sure they work out. And add another print statement. Very easy to kind of adjust it when you know it's working, right? And then down here, I'll just copy that, I guess, and add comma average 3. All I'm going to do different here is I'm going to feed in the other file, which has 3 columns, and it should adapt, right? So here comes the run. That one's just called input.txt. And notice. Now think about the capability of this, right? We're doing very simple calculations. We're doing it over a small data set. But I could ramp this up to process 100 columns and 1,000,000 records and do the same operations with this code. I would just have to update my code to accommodate that complexity, but it is completely possible. And we're doing averages. Okay, that's a basic operation. Think of all the other things that we could do with this data. So we're reading in a data set, separating it into columns, and performing mathematical operations on it. It's pretty impressive, actually. So this is kind of like, for data analytics people, maybe one of the first examples of what we can do with Python to process data. And I think that's pretty fascinating and empowering, if you feel that way about it. Maybe you don't feel that way about it at all. I really don't know. All right. For the next exercise, what I'm going to do is I'm going to show you 2 different versions of it. The one is like the brute force, let's just get it to work, which is really short. And then I'm going to show you or demonstrate a longer version for you if you want to make it run continuously like a real program might. Okay, so let's do that. Let's go back to our file folders. So start with file management here again. New folder. This is exercise 7.5. And I'm trying to look at the directives here and see if I need to find any additional files here from last year. And I think we do need them. So, all right. So let me just see what's in here. Okay. So I have the full version of the Beatles song Blackbird. So here that comes in the chat. So you guys can use the same file I'm using. I'm also going to copy that and then put it in my correct folder for this semester. All right. And then we will build from there. So a new program, save as, find the right folder though, folks. And this is exercise 7_5. All right. The direction for this one is actually pretty simple, right? It says write a program that asks the user for a file name and prints the number of characters, words, and lines in that file. Okay, this is kind of an interesting little task. And what I often do for people when I demonstrate this concept, right, of what we're doing, is if I take those words that I just put in the chat for you guys, and I'm trying to make sure I end up in the right folder here. So here's the Blackbird file, and I grab all of this text and copy it, and I go to Microsoft, go to Microsoft Word and paste them in. And I don't know if you guys are aware of this, but you notice I pasted it into Word, and right at the bottom here, where my mouse is, see where I'm hovering, right down there, it tells me right off the bat, I got 124 words. Thank you, Microsoft Word, because my English teachers always saying you need a 500-page paper, or, something goofy like that, right? And they count it. And so how do they count it? Well, it's built into Microsoft Word. Interesting. If you click this little tool in Microsoft Word, it brings up this whole little panel, and it says pages, words, characters with no spaces, characters with spaces, paragraphs, lines, non-Asian words, blah, 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 whatever, right? But it's giving me, I want you to notice, basically the same stuff, characters, words, and lines in the file. Okay, so that's kind of what we're doing, right? So the code we're writing is kind of the code that sits behind Microsoft Word and does it automatically for you, right? And a lot of people don't even know that tool is there, but it's a thing, right? Like you're like if you're writing a paper, you're often asked 5 pages, 500 words a page, something like that, right? You got to do it. All right. So let's start with the basics here. We need to read the file name from the user and open the file. All right, I'm going to do this in a little bit of a copy paste hurry up fashion. So here's kind of my thing. I'm going to start with a try block. I'm going to set up a variable for the file name, making it blank to start with. I'm setting up a counter. Why do I need a counter? I need counting stuff, right? All right, so I do count stuff, so I need a counter variable. And then I'm going to ask the user for the file name. So here's the prompt for the file name. All right, could I skip this step? Your brain is thinking yes, you are correct. Yeah, you totally skip that step. Why I did it last time, I'm not really sure, but I did it for some reason and I didn't leave notes for myself. So, hey, whatever. All right. So I'm actually going to delete that and go, you know what? I don't need that. All right. So prompting. Now I'm going to use this time I'm going to use a while loop. And I want you to think about this. What I'm doing here, and this is something we haven't done before, right? Is okay. I'm asking the user for the file. Okay, now I remember why I did it. All right, so let's put it back. It's to enable my while loop. Okay, so while my file name equals blank and the count is less than 3, so what's if the user doesn't type anything when they're prompted, what's going on? The file isn't found. So here I'm accommodating for the user just pressing enter at the prompt. That's what I'm doing. All right. Then I'm going to give them another chance to enter the file name, but that should go in a separate line. Prompt them again. And let's add one to the count. So we're going to give them, what are we doing? We're giving them 3 chances to put the file in correct, right? This is we haven't done this kind of stuff before, right? Usually, hey, if it's wrong, oops, it's wrong. Or if it's right, yay, it's right. And then we just move on. But this is the kind of logic that you use. So like, I'm giving them 3 chances. All they have to do is type something and it will work. All right, so then we'll do our in file and we'll open it. What are we opening? Well, the file name they gave us, hopefully it's right. Right, if not, we got the exception handler. We're just reading it. Do we need to write to a file if we're just counting the words and characters? Nope, we don't need to. And if it worked, we'll very simply say file successfully loaded. And if not, right, because there's some sort of, okay, if you want to put IO error, you can do it like that. That's fine. You can just say accept also. That's fine as well. And then just a very, very simple error message. Okay, well, this performs the first part of the operation, right? I mean, this is enough to read it in. So like this is kind of like my example of how to like keep a program running is really what I'm doing. So let's run this, right? And didn't type anything. Didn't type anything. Didn't type anything. And eventually it quits. All right. It went actually 4 times. They got 4 chances, really, but only 3 when they got into the loop. So this is kind of like my preliminary setup for this. And I might borrow from this as I do the full-blown thing. Okay. Let's re-engineer this. I just wanted to give you an example of how to keep it running. All right. So I'm going to make a copy of this and I'm going to call it, I guess I'll call it B, 75B. And I'm going to start Now, you know what? I'm looking at what I did here. I might borrow a little bit from this, but I think, let's see, you know what? I'm going to blow most of this away. Let's just do that. We'll just start over. I think it'll be easier, but I think we have at least an example now that we can pull from. Now, we want to limit their attempts to 3 tries. So I'm going to set up a variable called attempts equals, well, 0 to start with. That's how many they've made so far. Then I'm going to build this big while loop, and the whole program is going inside here. And I'm going to say, while attempts is less than 3, do the following actions, right? All right, we're going to prompt them for the file name. So same thing we did before, we'll say file name, input, and this is where you could have borrowed, I guess, this line, enter the file name, and maybe that's enough, enter the file name. All right, we're at risk of the code failing, so we do a try block, right? I'm going to teach you kind of like a weird little technique here. This maybe goes a little bit beyond what the book is doing, but I'm going to use this keyword here with, right, which is basically a way to kind of like leverage your code is the best way I can think of saying it. So we're going to try this. So we're going to try with this command to open the file in read mode. And we're going to set it as an in file. All right, so this is kind of a different technique here. So we're allowing it to read it all in, saving us the hassle of doing a separate read line on this. This command is doing that for us. And it's going to allow us to kind of shortcut a couple of steps. So this is kind of a handy little command if you guys want to do this. Now with every file or everything that we did, you know, it's going to process this. First thing I'm going to say is I'm putting in a little error, not an error message, it's a success message, just so we know we worked. That was, we can say file opened successfully. This is just kind of how my brain thinks, you know. I like to know that it worked, you know, not just when it fails. Then we're going to start keeping track of all the stuff inside the file. So in other words, we're going to have variables for all of these things. So here's my variable names. Characters, words, and lines. Right. Next, we need to start traversing the lines. Now, I want you to think about this, right? When we open the file here, we're saving it as an in file. That's kind of what this command does, right? So it's doing the opening and then taking the lines and putting them in the in file. So they're already separated in a variable called in file. You know, so that's kind of like the saving of that step that I was talking about. So now I am able to say for each line in the in file, well, every time I go through a line in the in file, well, I've added another line to the total. Okay. Pretty simple. How do I count the number of characters in a line? Well, I can look at that line. So for example, if I look at my file, right, I just go to the beginning and I go 1, 2, 3, 4, 5, 6, 7, you know, right, whatever. Really, how many characters are in this line with spaces? I just look at the length of the line. That's the answer, right? So the characters plus equals the length of the line. Simple as that. That's with spaces. If I want to count the words, then I plus equals Well, this is kind of a clever one here. First, I'm going to take the line and I'm going to run the split function to split it into words. Then I take the length of the result of that. So in other words, that will count the words. So that splits it into a list. Then I'm counting the length of the list. And I'm all set. And that's what value goes here. And notice, I'm not storing this. I'm processing it, extracting the length, and just storing the length here. I'm not really storing the words. I'm just processing them. All right, we're all done processing. In file close. Then we're left with the process of displaying the results. All right, so I try to make mine look kind of nice. This is the file contains so many characters, words, lines, and whatever. And you see how I'm trying to make it line up so it looks nice, basically. All right, this is where it gets a little weird. And this is showing some, I'll say, more advanced techniques here, right, in terms of working with loops. But I'm going to issue a break statement. Where have we seen a break statement before? In switch statements. You guys remember that? Or what do they call that? Match case statements here. And what this basically does is it will exit the loop if the file is successfully opened, is what that does. All right. This is the try block, right? So assuming it opens successfully, right? And that's kind of what this with statement does. It will process these commands and it will jump out, meaning we're done. Okay. Well, what if it fails? Right? Okay. So here's the different failures that we could have. And so I'm going back 2 indent levels on this. So we have one exception that can happen if, okay, file not found error. That's the command. And I don't want the parentheses there. Right, so if it's not finding the file, then I will output file not found. This is something that we haven't talked about, but you can have multiple exception errors depending on the kind of error that you're generating. So if it's an input-output error, then I can just say error opening the file. All right. So assuming they type in something valid, this will work. If they don't, it will hit one of these 2 error messages and then loop again, right? However, because we're tracking the number of attempts, I'll put in a variable for the number of attempts, and we are plus equaling 1. So we're tracking the number of attempts. All right. Finally, we're going to jump out of the loop. And I'm going to have just a little simple error message here. It says if attempts equal 3, and this is something you can add at the end. It's not really super critical, I guess. I think it's just polite to tell them, max attempts reached, exiting. Right. So at least they know they screwed up and why. You got 3 chances here, right, to put in the correct file name. All right. So this is the whole program. You're seeing it on the screen right now. So I'm going to go ahead and run this. Let's try it and see if it works. All right. So here goes. All right. Well, what's my file name? I don't know. Let's put in the wrong thing. All right. Notice it's giving me another chance. Oh, yeah. It was Blackbird, right? Blackbird. Oh, Blackbird. All right, misspelled it on purpose. Now let's do it correctly. characters, 647s, 124 words, and 18 lines. Is that what Microsoft Word told us? Yeah, that is correct, actually. Yeah, you guys don't remember, but believe it or not, I do. 124 words, characters, 18 lines. That seems to all match up to me. So now, whether or not they're counting characters with spaces or characters with no spaces, that's the basic code here, folks. If for any reason this approach is like maybe too complicated for you, you could go back to the first version. And if I was able to do all this, right, to load up the file, could I not take this code here, place it inside here, and actually, I guess I could add to this. Does it have to be inside the try block at this point if it opens successfully? Yeah. Well, you know what? It doesn't really matter too much, I suppose. But notice how it doesn't like the indenting. So I would be going through here, fixing all the indenting. You notice I'm trying to be really methodical about it because the other program was indented on a different level. But I just want to show you that we can get it to work also. All right, so here's the Control S to save if you guys want to screenshot this one before all right, and here goes. And I know we're past time, I get it. And here goes blackbird.txt. And we had one little failure here. 124. Line file. All right, so, okay, here. These commands. Right, these need to be unindented. I'm sure that would fix it.
Which one?
There you go. All right, so there's, the simpler version of it. And I don't know that it's really simpler, but the other one had a couple techniques. I know we ran out of time. Have to call it for the night, folks. Thank you guys for hanging out. The video ends here.